Hello and welcome to this Swift programming video. My name's David Thorne. In this video, we're going to be talking all about UnsafePointer and UnsafeMutablePointer in Swift. Now, this is a very, very low level thing in the Swift programming language. It might sound unsafe, but as long as you use it properly and you understand how to use it, then you should be able to be okay. Why would you want to be able to use UnsafePointer and MutablePointer? Well, if you've got to do very heavy, intensive computations, basically with lots of data, then get as closest to the memory at location of that one data as possible is the best, because it can speed up your application or those computations on orders of magnitude. Okay, so there is a massive difference. If you can move your computations all the way down to the sea level, you will see orders of magnitude more efficiency in your code. With that said, let's have a look at creating a simple UnsafePointer and UnsafeMutablePointer using the Swift programming language. Okay, let's just start with the traditional way first of all, and we'll convert from the traditional to then the UnsafePointer and UnsafeMutablePointer, so you understand how to bridge between the two of them. So quick reminder on variables. A variable that has been defined with let is immutable. A variable that's been defined with then var is immutable, all right, or mutable. And this goes for unsafe pointers and unsafe mutable pointers too. So even though you might use an unsafe mutable pointer that says, hey, I can change stuff, but if you're accessing a location in memory that is by default immutable, you're not going to be able to change it because the memory pointer said you can't change this anyway. So it doesn't matter. So all of the examples here will be assumed that you are using a variable instead, something that can be mutable. So with that now said, let's create a pointer, right, to this one value, and we will then say unsafe pointer, and we're going to start off with a unsafe pointer rather than the mutable one. And in here we need to pass it the value, okay, but we need to pass it a reference to this one value. Now you might have done C programming or any very, very low level programming, and you might have seen the ampersand before then the value. Now there, that would say this is the address for this one variable. This is not saying this in Swift, okay? That doesn't mean give me the address. And if we just go to show this right now and we say ampersand value and then even try and compile it, the ampersand used with a non-in-out argument of type any, okay? This is not saying give me an address, okay? What it's saying is to the unsafe pointer here is that this is an in-out parameter, all right? That's all it's saying. It's not saying give me the address. So once we have the pointer, we can then start talking about addresses and also values, okay, in here. So let's just create these placeholders for the address and the value. When we have the pointer is the unsafe pointer is the address, okay? And when we put it in a print statement, we automatically get then the address. You could say debug description is doing basically the same thing, but we don't have to in this sense. It is already going to be a number here. Now to get the value and that's at it, we'll just say pointee. Now if you've used C programming language and so on, you may have seen something like this, where we said then that this value is would start with then that this variable here is a pointer to an integer, and then before it would say then maybe num is then 42, and then we could initialize this one pointer variable with then ampersand num. That is basically what we've just done here to this one pointer, all right? And so then when we want to get the value at that one address, here, we would then say the star, and then we would say the value, all right? So we are looking inside of it and saying, hey, give me the actual value inside of this variable value, all right? Let's just call this pnum rather than that. So we're saying, give me, whoops, and then we put that in there. Let's say we give me the value as in 42 with inside of this one pointer. Okay, so this is the language that we're looking at if you were talking about C and so on. All right. So now that we understand this, the pointee is the value that's contained inside of the box, and the pointer is then the address. Now, in this example, we're only using an integer. So this means that it's only going to be accessing a integer size of memory, which is going to output an integer. If we were using an array, that is for another video, okay? And we're just going to outright leave it that it's for another video. So we're only working with an integer today, or float, or CG float, or double, or whatever. Basically a scalar property here. So as long as it's a scalar property, then this example is the same. All right. With that said, let's now have a look at how we can change that one value. All right. So we've seen when we run this, we can then get the address, and we get a hexadecimal address in memory. And this address is always going to stay the same for this one pointer this time. All right. If we rerun it again, we'll get another address memory, but this pointer address doesn't change. It's a place in physical memory on your machine. All right. And so if we want to change the value that's stored inside of that address, let's just do another print here and say pointee is equal to 43. So now you can see that the compiler is saying cannot assign property pointee as get only property. Now, so even though we've said we have a variable and we can change that one value using Swift, right? An unsafe pointer, it is basically doing the same thing as if we've said let value int equals 42. Okay. Now, in order for us to be able to change this one pointee and it have a setter as well, we're going to have to add the mutable pointer, or the mutable to the name as well. And this time when we run it, you can see that we get exactly the same address location here, but we get the value of 43 instead. This is all well and good, right? Is that we've taken a value in the Swift framework, and this is, let's just make this clear, this is managed by Swift. Okay, this is managed by Swift. And now we want to have is managed by the application, all right? And this is managed by our code now that we're going to write here. So we want to now create another pointer. Let's call it pointer 1. And this, once again, is going to be an unsafe pointer. But when we want to create our own memory, we're going to have to be able to manipulate that part of memory, okay? And so we're going to have to say UnsafeMutablePointer. And we're going to say what size that one pointer, that place in memory is going to be. And now we want to allocate the capacity of it, right? So we're saying, hey, every chunk of memory that you create, here's the number of chunks consecutively that I want you to create. And we're just going to say 1, all right? So it's going to create one place in memory at the size of int. Now that we have allocated a place in memory for one integer, we're going to need to initialize it, right? We have declared our place in memory, and now we need to do initialization. And it's the same as here, all right? Is we have said, hey, we're giving this one place in memory a name, and we've said what type it is. That's the same as here. And we have then declared it. And this is basically declaring it, and it's allocating that space in memory. But now we need to initialize it, and this is then the initializer side of it. Remember, we don't have to do declaration and initialization on the same line. We can do it like this as well, all right? And this is something that's got to happen as well now to our pointer. We need to initialize it rather than access it straight away. And so now we're going to initialize it with the value of 42. And when we now copy and paste this, and we put pointer 1 here, and then put pointer 1 here, and we run this, you can see now that we get a new address level, and then value of 42. So let's comment this out, and let's do pointer 1, and we'll say pointee, and then do 42, and see what happens now. When we run this, you do see that we get the value of 42, but this isn't guaranteed. If you look at the actual documentation to this, you say when reading the pointee property, the instance referenced by the pointer must be initialized. When pointee is used as the left side of an assignment, the instance is updated. The instant must be initialized, or this pointer's pointee type must be a trivial type. Uninitialized memory cannot be initialized to a non-trivial type using pointee. Instead, use this. So you can see here that you may get strange. It's not guaranteeing that you actually get in that one value. So you're going to have to make sure that you you initialize the value in the beginning. Obviously now we're getting the value of 42 there, right? And when we run it again, we get 43. So just because you can access this one pointee, it doesn't necessarily mean to say that it's actually setting it, right? So be warned that you do need to initialize the pointer before you actually access and use the pointee itself, okay? But in this situation, it worked perfectly fine, but there's no guarantee that that is going to work. If it says it must be initialized beforehand, the fact that it has initialized it to that is something that I'm sure is happening in the background, okay? And if we run it maybe 1,000 times, you probably might get 0 there or another number. So now that we've seen this, there's another thing that we have to understand is that this is managed by Swift and this is managed by us, the application. That's really important that we understand when we allocate some memory, we need to deallocate it because we are managing the application, or sorry, we are managing those places in memory. So that is easily done. It's done with deallocate here, nice and simple. So when you're finished with that memory, deallocate it, all right? And when we look at the actual address and the value now at the pointer1 pointee, you'll see what we get. You see we get the same address in memory, which is normal because we're just deallocating it. We're saying, hey, memory, you can have it back again. But now the pointee is something completely different. Even though we haven't set it to anything, the memory just got randomly set back to something else, okay? So you can see that it could have been 43 still. It's all down to the memory, how they clean up the memory places or whatever, all right? Something else could have been then given that piece of memory. I don't know. But the whole point is once you've deallocated it, you shouldn't really start reading it once again because you don't, or you shouldn't change it once again because you don't own that one location. So if we do come here and we do say pointee is equal to 42 once again and run it, you can see that the code exited perfectly fine. If we run this and run it again to see what we get, we still get the value of 42, all right? But what we have done is to the application said, hey, we are finished with it now. We've deallocated it, but that's not stopping the memory from giving it to someone else. This, prior to the deallocation, means that, hey, we own it and no one else is going to get it. But you can see how we can still read and set into the application. Now, if we did this all over the place, right, we could break the application. And it is very, very well known in other platforms that you can break applications or add viruses on by doing this type of stuff. So with that said, the final thing to talk about is managed by Swift stuff. If we say we are now finished with this one pointer here, and we turn around and say, we want pointer, and we say deallocate here, we're finished with this pointer, we don't need it anymore. Be warned. You can see here, boom, that crashes the application outright. So you can see down here that the accessing this pointee once again doesn't do anything. It says, I know this has got that place in memory and I'll give you the location, I'll give you the value of it and you can set it once again, all right? But deallocating something that you are not managing, all right, is not permitted, and that's enough to crash the application. So if you manage it, you can deallocate it, right? Or in other words, if you allocated it, you can deallocate it. That is it. So you've got to be very careful that if you do receive a pointer and you know you allocated it and you want to do cleanup, then deallocate it as well, all right? Now, another thing is to note that if this pointer has been created within a closure, okay? Now, other variables, let's just say, for example, that we have test is equal to then void here, and we create a variable of L2 here, right? When we call test here, this variable L is getting initialized and then it's getting removed, okay? It's just completely gone. Pointers aren't like that. Pointers, once they're created, especially when you say allocate. That piece of memory is allocated. So if you don't access or keep a reference to this one pointer afterwards, then you're going to have some form of memory leak, all right? So if you're going to use this one pointer, at least keep a reference to it so you can deallocate it in the future. So when you place that in here, this one memory location, this piece of memory is going to still be there even though this code block has finished. This one won't be there, all right? But this is you managing this one code, all right? You are managing this, right? It's managed by the application. They are saying that you've taken the responsibility on to manage this, all right? So with that said, I hope that you've got something out this one video. If this is all completely new to you, then well done for watching all the way through. There are a few other topics that I want to talk about, I want to make videos about, but as I was doing them, I was noticing there were lots of question marks, lots of areas where people could then think, I don't know about this, and I might lose you. I might lose you, and then you have to go off to another channel or another place to watch it, or you don't know how to go on any further. So I much prefer teaching you about the small things first, and then as you build up, you understand the programming language at a very low level. Now, if you've never done C programming before, then if you move to C programming, and we will in the future start adding C files to our applications to access real low-level tools, then this stuff is going to become a lot more easier to understand, because under the C level, you're going to think, well, no, wait a minute, I understand this at a C level, and a Swift level is just understanding which objects and which classes and namespaces I have to use, and what do I write. So it should help you in the future. Other than that, if it did help you, then don't forget to like, subscribe, share. That will just maybe help another person to find this video so it could help them too. If you do have any questions, feedback or concerns, as always, please feel free to write any of the stuff in the comment section down below, and we can have a conversation about it. Other than that, thank you very much for watching. My name's David Thorne. See you in the next video. Ciao, ciao, and goodbye.